for your review so you can figure out how to do them. I'm going to go over a majority of them today. The goal of solving a word problem, there are steps, just like solving an equation, that if you follow them, your brain at least becomes a little bit clearer. If you just read the word problem or are confused and then skip it, that's not actually doing you any good, because I'm trying to guarantee that you do not pass the first test if you don't know how to do these. These crop up all semester long, and I at least try to put 3 on every test. So you need to learn how to do these, because this is how the world comes to you. It doesn't come to you as an equation. It comes to you as a problem that your boss is going to be like, this is what's going on and I need you to figure it out. That's the type of thinking you need to have, is technically these steps. So number 1, do not skip this. I have had people skip it completely. They see words, they don't even read the words, and they skip to the next problem. I have seen people define a word problem as a bunch of words. It gives you a nice little equation to plug into and what to do with that equation. And they consider that a word problem. That's just a problem that has words, because technically all you have to do is take a number, plug it into the equation, and generate an answer. These are a little different. You have to generate the equation to find the answer. So the first thing you're going to do is read the problem. Second thing you're going to do, and by the way, this is how I do it. I read a word problem. The first time I read it, I'm clueless. I get some ideas going in my head, but I don't know it right off the top of my head, unless I've seen that type of word problem over and over and over again. So when you read the word problem the first time, you're going to be a little lost. That's natural. Everybody does it, including me. So you have to read it again. When you read it the second time, you start picking out key elements, key ideas. What kind of organization has to come to your brain at this point? Step number 3. Organize. Organize the info that they have given you. Sometimes they give you so much information that you don't know what to do with it. They might be talking about cashews, peanuts, and a mixture. You might want to put everything that has to do with cashews in one location, peanuts in another location, mixture in another location, so you can keep your information kind of separate. Sometimes you might have geometric figures you have to worry about. Circles, rectangles, triangles, right triangles, things like that. You might want to table, draw a picture. Oops, draw a picture. And if, there's other ideas that you could do, but those are the 2 big ones that people don't like doing. Especially when it's geometric. A lot of people try to do it in their heads and they goof off because they don't really see the whole shape in their heads. A lot of people do not hold images in their head very well. So drawing it on a piece of paper is actually a better idea. 4, set up. The requirement of the problem, what's it talking about? Is it talking about a specific formula? Distance equals rate times time, interest equals principal times rate, any weird formula, length equal, or perimeter equals 2 lengths plus 2w, things like that. And choose X as most unknown. There's going to be some idea in the word problem that is the least known about. That's the one you want to choose as your variable. If you know something about a situation, you can use the variable to define it, but the one you know nothing about, that's the one that gets the X. 5, solve. 6, check validity. If you get an answer, I'm going to give you, for instance, I asked you to paint this room. You do the work on the problem, you come up with 80 gallons of paint. Do you think it would take 80 gallons of paint to paint this room? Heck no. So sometimes when you get an answer, it just makes absolutely no sense. You might want to go check your units, make sure you didn't move a decimal place, signs, weird things like that will screw up a problem. So, read, organize, set up an equation based on your unknown variable x, solve your equation, check your answer. And the only thing you can check is pretty much, does it make sense? Alright, so what should we start with? Nah, that one's boring. Let me hit you with two that you should know already. Ready? Before I go about answering this question, I want to talk about what does it mean to take 20% off. I need a new marker. Because a lot of people do it a little weird, and for algebra's sakes, you need to do it a very specific way. 8th grade style works fine, except it won't get you to the answer of this problem. So when you take 20% off an item, let's say for instance, do a side problem. Oh, by the way, this is also a perfectly fine way of solving a word problem. If you don't like the direction it's solving in, you could always try to do something going in a normal direction that you're used to, and then go backwards. So this is kind of going the wrong direction to figure out what the heck we're supposed to do. So let's say I have a $75 item. And need price for 20% off. This marker's dying too. So, how do you take 20% off of an item?
Multiply the cost by 20%.
Multiply the cost by 20%, so you'd go 0.20 times $75. Get an answer. What is it? You all have calculators, right? Quadratic formula in my way of doing it without a calculator. So, what's 20% of 75? What is it, 15? $15, and then you take the $15 and you subtract it away from the 75. So your sale price would be, $75 minus $15, better known as $60. Woohoo! Great. That's 8th grade style. Algebra style changes it just a little bit. Instead of saying $75, they would say X dollars, and then find 20% off. So same problem, except now we're going to use a variable. So when we use a variable, we're going to try to set it up, lengthwise, left to right rather than that up to down style I have there. So the first thing we did over here is we took 20% of the cost of the item. So I would do 0.20 times x. I would find that answer, whatever the heck it is. Over here it was $15, but that would be the representation of the $15. What did I do with this? What did you do with the $15 over here? Subtract it away from the original price. Well, this represents the $15, so I'm going to subtract this away from... No. We're in the blue part here, not the green. What's the original price? X. So X in this case represents $75. So here, 0.2 times X, got an answer, 0.2X. Took my original number, which is X, and subtracted 0.2X. I know, algebra is a wonderful thing. So the problem with 8th grade style is you have to know the numbers. The nice thing about algebra style is you don't have to know the numbers. And it gives you a simple expression to figure it out. So wherever there was a 75 over here, I just replaced it with X. So this is 0.2X, 0.2X, taken away from the original number, which was X. Now, the cool thing is, what's X minus 0.2X? Okay, ready? How do you combine like terms? If you don't know, you take the X and you factor it out, right? Remember? Distributive property? Holy God, did we lose a brain cell or two over the week? How many went drinking on Monday and Sunday and Saturday? Don't answer that question. What number's in front of us? 1. What can I kick out? X. Once I kick out the X, what's left behind? And what's 1 minus 0.2? 0.8. So, this is really cool. Ready? On your calculators, do 75 times 0.8. I guarantee you the answer is 60. It is. Up here, you had to do 2 calculations to get to your answer. Using algebra, we really only need 1. Which is kind of neat if you think about it. So there's a different way of thinking about this. This is 20% off, and you would multiply by 0.2 and subtract it away. This is 80% of, instead of off. It's much easier to take a percent of a number than a percent off of a number. So if you go to a store and it's 30% off, how much of the cost are you paying? 70%. It's the opposite end. This way you calculate, you figure out how much you're saving. The other way you're figuring out how much you're paying. Now, when you go to the store, do you care about what you're saving or what you're paying? I find that shoppers only care about the savings. They don't care about how much money is going out of their pocket. I'm more with this style. I go in and I figure out how much it costs, and I'm like, oh, that's way too much. I'll walk out. I don't care. So, this is how we're going to have to solve the problem. You can't do it 8th grade style. You have to use this idea. So, what's our unknown?
The original cost.
The original cost. So, for this problem, let's come down here. We're going to let x equal original cost, in dollars, of course. And the problem says it already was taken 20% off. Well, how do I take 20% off of x? Well, I could go this route, but it's much easier to go that route. So it sets up as, well, I took 20% off of x, which is the same thing as 80% of the cost. And 80% of the cost must equal $375, the sale price. How do you solve for x?
Divide by 80%.
Divide by the 80%. So you're going to get x is equal to 375 divided by 0.8, better known as 468. 468.75? 0.75. So the original cost of this TV was $468.75. Wouldn't it be much easier to go shopping if the tax was already included in the price? I mean, they know what the tax of an item is going to be. Why couldn't they just put it on this sticker to begin with? It just makes more sense to me. Oh, well, I guess people are like, oh, it's $20 instead of $23.20. I don't know. So the total cost of the register is $38.50. Well, of course, this is after 7% tax was added onto it. So again, we're going to have to change this into algebra. Do you want me to do it 8th grade style first? Or do you think we can figure it out algebra style right off the bat? Let's go with algebra. We'll see how well. What's our unknown? Well, let x equal
How much it was before tax?
cost before tax. So if x is the cost before tax, how do I find 7% tax on x dollars? Multiply by 0.07, so go 0.07 times x. That's your tax. What do I do with my tax? And I hope so. I've had people subtract it. I wish tax was subtracted. Wouldn't that be great? Lower the cost of things. But it is added back to the original cost, which happens to be x. So what is x plus 0.07x? What number's in front of the x? 1. You kick out the x, kind of like before. What's left behind? 1 plus 0.07. What's 1 plus 0.07? 1.07. So to find the tax on an item, you take the item, you multiply it by 1.07. The 1 actually represents the original cost. And then the 0.07 is the addition of tax. So if you get a 20% raise at work, if you know what your salary is, you multiply by 1.2. It gives you your 1 is your original salary, the 0.2 is your 20% increase. All right, so this 1.07x is the total cost of an item after tax. Well, what's the total cost of the item? Items. Well, that's equal to 38.50. So, how do I solve for x? Divide. So you take 38.50 and you divide it by 1.07. Which equals? Now it's going to be money, and I don't think it's going to come out nice. So, what is it? $35.98. So the original cost of the items before tax was $35.98. Ta-da! For some reason, I'll have harder word problems. People are better with the harder word problems than they are with money. And I don't understand because you work with money every day. But I think you don't think about it. You just kind of hand off your credit card and whatever they charge you, whatever, you know. You don't think about it too much. So let's make it harder. Wouldn't that be nice? Uncle Joe left you a little bit of money. Mic up in a second. Let's make it $500. wordy word problem. Uncle Joe left you at $7,000 for tax purposes. You need to only make $500 in interest for the year. So you split the money into two accounts. One earns 4.5% interest and the other 9% interest. Little note. It is not compound interest. That would make the problem nearly impossible to solve. But it is simple interest. Does anybody know the simple interest formula? P something, yeah. I equals PRT. So the simple interest formula is I equals PRT. I know, it's been a while. We know one of these is guaranteed for both accounts. What is T equal to?
Time.
And the time that the money is in these accounts is? 12 months. The year. So in this case, T is equal to 1. So the formula we're going to be working with is I equals PR. Because PR times 1 is PR. Okay, now this is one of those problems that there's two things going on. Actually, three things going on. But you have to be careful about the first two. So I highly suggest some kind of table format. So there's two things going on. One of the accounts is earning 4.5% interest. The other one is earning 9%. How much money do I put at 4.5%? X. I don't know, so I'm going to put X. So this is X dollars into this account. How much money is going into at 9%? Can't be X, because X is already used up, and I'm not sure that the amounts are going to be equal. They might be a little. We could call it Y, but then you're getting into something called system of equations, and I don't know anything about that yet. Is it X minus 500? Does the 500 have something to do with how much money is going into the account? Let me ask this. If I put $1,000 at 4.5%, how much money do I have to go for 9?
What's left over?
How much is left over? 6,000. If I put $2,000 at 4.5%, how much money goes at 9?
So you don't need nothing for that.
Oh, I said 2, right?
Oh, 5.
5 over here, right? So what are you doing with this number that you have here? If this was 2,000, how did you find this one was 5?
You subtract it from the 7,000.
We subtract it from the 7,000. So how much money is going at 9%? 7,000 minus X. And that's the best way to get the order. Put a number in for X and see what the heck you do with it, and then just do the same thing with the X. The biggest mistake here is I've had people write X minus 7,000. It gives you negative answers at the end. Okay, so, oh, by the way, I'm just curious. Why would he only want $500 of interest? Why not throw all the money at 9%? What kind of tax-related issue would come up if you make too much money?
It can put you in a high tax bracket.
Put you in a higher tax bracket, and then you lose all the money that you just earned, which is kind of, detrimental. All right, so using this formula, I equals PR, we need to set up how much interest did I earn from this account? What's the principal? What's the principal here? Principal is how much money you're putting in the bank. X. What's the interest rate? 4.5. So this becomes 0.045. Don't write 45 because that would be 45% interest, and if I could find a bank account that had that, I'd throw everything into it. Times X. So this is I equals PR. I just reversed the order because variables usually go last. How much interest did I gain from the second account? 9%, so you go 0.09 times, what's the principal over there?
7,000.
Don't lose a 0.
7,000.
7,000. That's another common mistake. When a lot of zeros are involved, people either A, drop them, or B, get rid of them, or add too many of them. And it throws your answer off by 10 one way or the other. Now, this is how much interest you're earning from the first account. This is how much interest you're earning from the second account. And I need these two interests to, well, before I equal, I need to do something to them first.
That should add 500.
Well, I know they have to add up to 500. So they have to add together to be 500. They have to total out to 500. All right, now it's a nice simple equation. I expect you to be able to solve it. Yeah, go ahead. Oh, you think I'm going to do it? Told you, I don't know how to do calculations. The worst thing in a math class is sitting there watching me. The way to make a math class go really fast is to do it all on your own, without waiting for me. When I was in a math class, I would have the problem done before the teacher was talking about it so I could check my answer to what they came up with.
0.045x plus 630 minus 0.09x equals 500.
Okay, I'll go with that.
Combine those like times.
Yeah, what are they? By now, I assume that you know how to do most of the simple steps of solving a linear equation. What is it?
The 0.045x and the 0.09x.
Yeah, subtract them and you get. Yeah, I don't know how to do calculations.
0.045.
Negative 0.4.
Yeah.
Negative 0.045x. Oops, my fives are ugly. Plus 630 is equal to 500. Don't let that negative throw you. It's perfectly fine. Because when you move the 630 over, that's going to produce another negative number. And then a negative is going to make a positive. So that's perfectly fine. So this is negative 0.045x is equal to negative 130? Fine, I did one calculation for you. And then, I'm not doing this one in my head, so divide both sides by negative 0.045. Be really careful that you don't type in 0.45 or 0.0045. Make sure you type in what's on the paper. So x is equal to. It's not going to be nice. At least I don't think it is. No. I made up a problem, so it generally comes up ugly. What's it come up to be? So if we're talking about money, 289. And don't forget, if you write this on the paper, I take off a point. Why? Oh, I in my list of how to solve an equation, I forgot one step. The last step is answer the question. How much money went into both accounts? Well, what is this? It's money. I need a dollar sign in front of it. And I need to say where it's going. Well, where's it going?
Into the 4.5.
Into 4.5. Now, how do I find out how much goes at 9%?
Subtract that from 7,000.
So 7,000 minus 28888.89. I have no idea what that is. My guess? No, I'm not even going to guess. 4 something.
$4,111.11.
And this would be properly answering the question. How much money went into both accounts? This one went into 4.5%. This amount went into 9%. Whew. This has a fancy name to it. This is called a mixture problem. And there are different varieties of mixture problems. One variety, of course, is money. Another one is my cashews peanuts problem. And you do a mixture of cashews, peanuts, and they have a certain price per pound for the cashews and the peanuts, and you want to come up with this new mixture. So that's why these are called mixture problems. There's also a chemistry. Anybody taking chemistry? No one taking chemistry? You eventually have to do labs, and you have to do mixtures to make sure your acids are at a certain percentage, and you have to do some work that looks a lot like this. So these problems crop up pretty much everywhere. Financial, chemistry, business. What else could I throw at you? Geometry?
Nothing.
We can do geometry. Geometric problem, for example. By the end of the semester, you're going to get sick of my Farmer Joe here. Farmer Joe has several different types of problems, but he's always putting in a fence, and he's always containing some kind of field. This one is simplistic. Some of the other ones get a little bit more rambunctious.
Oh, yeah.
Now, I highly suggest anytime you're dealing with Farmer Joe and his fields, which happen to be rectangular in shape, draw a picture.
I don't know about the dog.
No dogs yet. We'll get to him later, the kennel. This thing is a rectangle. What's true about rectangles?
The length
Ah,
are
4
the
right
same.
angles. 1, 2, 3, 4. That's a good one. What else?
The lengths are the same.
The opposite sides are exactly the same, right? And they're parallel. That's the third property. So if I have this thing, when you talk about I'm going to put 1,500 feet of fence around it, am I putting the fence in here, in the middle? What is the stuff in the middle called? Area. Where am I putting the fence?
Around.
Around the edge. What's that called? Perimeter. When you're dealing with a rectangle, there's always a length and a width. I don't care which side you label length and width. The length does not have to necessarily be the longest side. It could be the shortest side. It doesn't really matter. How do I find the perimeter of any object? Add up all the sides. So if this side is L, and we just talked about the other side being exactly the same, this would be L and L, which is 2L plus 2W. Now this is the perimeter of an entire rectangle. Some of my rectangles are missing a side, so you have to be a little cautious. It's not always going to be 2L plus 2W. But the perimeter of a rectangle, that's the formula. So, might as well use it. Do I know what the perimeter of this object is going to be?
1,500.
1,500. So I can put that there. But then when I get to 2L plus 2W, that's way too many variables. So I have to choose my X. So what should X be?
Why?
Well, when you read the problem, a farmer has 1,500 feet of fencing. His enclosure will be 175 feet longer than it is wide. So which side is the most unknown? The width. I know a little bit more about the length because it has this 175 associated with it. So I'm going to let W equal X. So what does that make L equal to?
X plus 175.
X plus 175.
Yeah,
See,
but
if you organize problems, things become a little bit, well, easier. And then you can just kind of flow through it and get an answer. So I've set it up. When you're substituting, I highly suggest the first thing you put down, besides the number that goes in here, is an empty set of parentheses. Because this expression here has 2 pieces to it. If you left off the parentheses, you'd have 2 times x plus 175, which is not what it is. So what goes inside the parentheses is x plus 175, and you see that the 2 has to distribute. That's very important. The W is not so important, but I'm still going to put it in parentheses to try to get into a habit. What goes inside this set of parentheses is just plain old x. So we get this nice equation, numbers and 1 variable. That's important. You can't have 2. You can only have 1. So go through your process. This becomes 1,500 is equal to 2x plus 350 plus 2x again. All right? After you distribute, what should you do next? Combine like terms. 1,500 is equal to 4x plus 350. And then just solve for x. What do I move first? 350. Subtracting, what is it? Come on, geniuses.
1150.
1150. 1150, right? For those with calculators. 1150 equals 4x. Okay, divide by 4.
287.
Thank you. 280 as in 50.50. So x is equal to 287.5.
And then you gotta find out what the length is, so you gotta add 175.
And add 175. But before I get there, 287.5 feet. And then the other one is going to be 175 plus 287.5 for a grand total of
462.5 feet.
so the dimensions of his field have to be 287.5 wide and 462.5 feet long. And that'll use up all his 1,500 feet of fencing.
Well, see, honestly, if I would have done that, like, by myself, I would have thought 175 feet, you know, you would have divided it by two and split it on two sides. And so it actually wouldn't have got that answer.
Wouldn't have got that answer?
Would it?
I don't know. Try it. But for...
I mean, you know what I'm saying?
I know what you're saying. There's ways of doing this without algebra, but eventually...
Well, I mean, it would have been in algebra, but it wouldn't have been, you know,
Written
2x
out.
plus 175. It actually would have been 2x plus half of 175, since it's two sides. You know what I'm saying? I mean, does that make sense?
I think so, but I'm saying that the length is 175 longer on both of them.
We'll see. I mean, you
Not
know,
half
if
and
I would
half.
actually, I would have thought deeper into it. I'd be like, okay,
No, don't do that.
175, and then
Keep it
like
simple.
divided by 2, and
No.
then I would have done something wrong.
Yeah, keep it simple. Keep it simple. But there are people, like, if you do construction a lot, they can do this in their heads. They can figure out what the dimensions have to be. I had a guy that did that. He's like, can I do that? I'm like, no, I need to see the work. Choice, quiz, or just go on break?
Right.
Okay, I figured your brains are dead. Quiz at the end of class then. In my video, last geometry problem. And then I'll throw a bunch of homework problems your way, a bunch of word problems. There's one little topic in here that has nothing to do with word problems, and I find it really easy, but a lot of people find it very, well, horrendous because it has no numbers. But I think working without numbers is nice because you don't have to do any calculations whatsoever. So that's the last thing we're going to do in this section. It's actually a very long section. Some of these other ones like P4 or P4. 1-4 is going to go really, really quick. I'll teach that in about 10 minutes because I don't want to spend a ton of time on it. All right, so here we have a pool. Its measurements are 40 feet by 30 feet. Not a huge pool, but decent size. It has a path around it, like a stone path or a cement path or something around it. Has uniform width, so it doesn't change its width as it goes around the pool. It's always certain feet away from the pool. And what we want to do is we want to find the width of this path if there's a fence that goes around the whole thing, path and pool combined, and the length of that thing is 164 feet. So, question, what would you do first? Draw a pool. Start with a pool. It's the best place to start. So here's your pool. I'll even label it. Pool. And it is 40 feet by 30 feet. All right. What's going around this pool? A path first and then a fence. But the fence is right on the edge of the path, so I can just put the fence if you want. I could have said the fence is a uniform distance away from the pool. And the pool gets centered. The pool doesn't touch the fence, so it's centered in this other rectangle. There's a concentric circle. What's the name for other geometric shapes inside one? I can't think of it right now. What's the other thing that I need in my picture?
164.
Well, that 164, but it doesn't go on a specific side. It's the entire green perimeter. So it's the perimeter of that fence.
Oh, that's the length.
Yeah. So that's why I got rid of in length. I was going to say in length, but I wanted around the whole thing. So what is my unknown? I mean, that's really important in word problems. What don't I know?
The width of the path.
The width of the path. So let x equal width of path. So where do I measure it in my picture?
In between the pool and the fence.
In between the pool and the fence. So this distance from here to here is x feet. Well, if that's x feet, so is the distance from here to here. Because it has to be uniform. So is the distance between here and here, and here and here. So all those black little arrows are just x feet in length. So, what do I need to find?
The length of fence.
The length of the green side here. How long is this green side in the bottom? Well, let me ask it a different way. We'll come back to I heard you. If you bring this down to here, and you bring this side down to here, how far is it from here to here?
40.
40. How far is it from here to here? Just from here to here. X, right? How far is it from here to here? X. So how long is this whole side?
40x squared?
Oh! Stab me a few times in the heart and kill me. If this is 5 feet and this is 5 feet, how long would it be? It would be 40 plus 10, right? Not 10 squared or 5 squared. It would just be added. What's x plus x?
40 plus 2x.
Thank you. Remember I talked about that last class?
Yeah.
And I'm dead on the floor now, bleeding. Thank you. Jeez. All right, so this would be 2x plus 40, or 40 plus 2x. It's irrelevant which way you write it. And this is why pictures are nice, because you can see why it actually is the way it is. Similarly, I can never say that word right. Similarly, whatever. What's the length of this side? Well, if you go from here to here, this is 30 feet, right? What's the top portion? X. What's the bottom portion? So it's going to be 30 plus 2x. So the dimensions of this fence outside of the path, or the edge of the path, is 2x plus 40 and 2x plus 30. Remember, you can flip the order because of the commutative properties. So again, we're going to use the perimeter formula and plug in what we know. Do we know the perimeter of this object? 164, right? Where is it? There it is. 164. So this gets a 164. 2 times the length. Well, what's the length of this path?
2x plus 40.
2x plus 40. Plus 2 times, well, what's the width of this object? 30 plus 2x, 2x plus 30. I'm going to write it as 2x plus 30 just to be similar to the first one. And you get a nice little equation out of it. But most of this equation comes from the picture, nothing else. Just the picture and understanding how the pieces come together. I think you can solve it from there, but let's go real quick. 164 is equal to 4x plus 80 plus 4x plus 60, right? Well, I'm doing calculations. I should make you do those. Oh well. 164 is equal to 8x plus 140. Subtract 140 across and you get 24, right? Is equal to 8x. And x is equal to 3. And if you leave that on the test, 2 points off. Or did I say 1? I forget. 1 point off. I mean, you put a lot of effort into it up to that point. But the answer is the question. Find the width of the path if the fence is blah, blah, blah. So the width of the path is 3 feet. Make sure you answer the question, or make sure you answer this. Tell me what I'm looking for. All right. Oh, I know what I have to do next. Now, the other thing you have to work with is, well, formulas. That was a kid, wasn't it? I hope that wasn't an adult. That would be really scary. Formulas. Manipulating formulas to become something different. Start off with something easy. For example, if I give you this formula, does anybody know what this formula is?
Triangle.
Area of a triangle. Generally, when you're doing the area of a triangle, you're given a base, you're given a height, you plug it into the formula, and you get the answer for the area in square feet, square meters, whatever it's going to be. But there are certain cases when you know what the area is, and you're looking for the base or the height. And the best way to do it, let's say, for instance, I tell you that the area is 20 square feet, and the height is 5 feet. Find the base. What would you do?
Get the base back.
Well, you plug in the numbers first, and you get the variable that you're solving for by itself. So what's area equal to? Well, 20 is equal to 1/2. What's the base equal to? Base. We don't know what that is. And the height is? 5. So our equation becomes 20 equals 5 over 2b. We do all understand that 1/2 times 5 is 5 over 2. I've had people yell at me about doing that too quickly. Are you sure? Because I worry when fractions get involved. How do you solve this equation?
You divide. No, first.
Multiply by its multiplicative inverse, which is 2 over 5. Remember we talked about inverses and reciprocals as inverses? So if I multiply both sides by 2 over 5, that should give me my answer. The 2's cancel, the 5's cancel, and you're left with b. 5 goes into 20. 4. 4 times 2 is 8. So we get, the base has to be 8 feet. What if I give you a different area, a different height, and I still want you to find base? You'd have to go through the same process to find it. Agreed? How many times would you want to go through the same process? Me? Once. If I ask you again, area equals 100 square feet, height equals 5.75 feet, find the base. You'd have to do the same basic steps to this to get to the same basic type of answer. So why not, right from the beginning, take this equation and solve it for the variable. You don't need numbers to manipulate this. Numbers are nice because you're used to them, but you really don't need them. How would you solve this equation for b? What would be your first step? Okay, let me rephrase that. What would be my first step?
1/2 times.
Nope. We all forgot our steps of solving an equation. What was step 1 in solving a linear equation? Get rid of your fractions. How do I get rid of the fractions here? Multiply by 2, or 2 over 1, doesn't matter. So multiply this side by 2, multiply this side by 2. Why would you do anything different? That's the danger of math. If you see a problem, you know how to do it and you get to the answer. If you see another problem that's a little different, you think it has to be done differently. And technically, they're both linear equations. We're just trying to get that variable by itself. And when I say that's the variable, these other two become what's known as constants, even though they're still letters. I treat him as the variable. I treat the other two as numbers. So I multiply everything by 2. This side becomes 2a equals, what's this side become? Say that again. I love that. BH, BH. Right? Doesn't it sound like that? I always want to change the formula to length and width. 1/2 length width, get it out of the way. BH. But it's important that it's 2 times 1/2 is 1, 1 times BH is BH. Yes, I do have some humor. Not much. Okay. Now, your focus has to come back to the letter that you're solving for, the B. How do I get B by itself?
You have to divide
by h. So divide both sides by h. And you get this new equation where B is equal to 2 times the area divided by the height. All right, let's test it out. Go back to the original problem over here. A is equal to 20, h is equal to 5. So this would be 2 times 20, 40, divided by 5. 8. Get you to the answer in one step. That's the beauty of algebra. You can manipulate formulas into something else to make your life, well, easier. If I ask multiple times, A is this, H is this, find B. A is this, H is this, find B. Are they always that nice and easy? Yes. As long as you don't treat it any different than a linear equation, you're safe. If you follow those steps of solving a linear equation, you're safe. Seriously. there should be no errors with these. If you know how to do it with numbers, you should be able to do it with letters. Can I make it uglier? Yeah. What's this formula? Trapezoid. It's the area of a trapezoid. You know, one of those shapes that look like this. Two parallel sides, not necessarily the same length. You get that? Never seen this picture before?
Yep.
I consider this the little base and this the big base, and the height of the object is the right angle height here. So that's what this formula is talking about, the area of a trapezoid. All right, let's say I want to solve for big B. Why not? How would you solve for big B in this expression, this equation? I should be really careful. Expressions don't have an equal sign. Equations do. How do I solve for big B in this equation?
Times everything by 2.
You can start off by multiplying everything by 2. So multiply this side by 2, multiply this side by 2. The good thing about that is no more fractions. It just goes away. So this becomes 2 times A, better known as 2A. 2 times a half? 1. 1 times H? H. And we still have the quantity B plus B. Now what?
Divide H on both sides.
You could. Or
Distribute.
distribute. Now that's a choice you get to make. You can either A, distribute the H, which is normal steps for solving a linear equation, or you can get fancy and get the H to the other side right away. Which one do you want to do? Neither of them are wrong.
Get
I
H.
get the H on
And
right
the
there. That's
quicker.
more work if you
Yeah,
distribute
quicker.
and then
No, well, okay. Move the H over. It looks a little funny when you do it that way, though. So divide both sides by H. So you get 2A over H is equal to
B plus big B plus B.
do I need the parentheses anymore?
No.
No. Nothing's holding it in place, so you get big B plus B. Or if you want, H divided by H is 1. You can distribute the 1 and you get B plus B. Alright, we're solving for big B. You always want to go back to the variable you're trying to solve for. I've had people do this and they switch which variable they're solving for. So make sure you go back. Oh yeah, big B. Keep your attention on him. If I'm solving for him, what do I need to move?
A little bit.
A little b. How do I move it?
Subtract.
Subtract it from both sides. Now this is where people do weird things, and this is where I'd rather you distribute that h in the beginning. Because I have seen people write it this way. Don't write this. Is that correct?
Mm-hmm.
Yes, no?
No.
No, yes.
No.
Which one?
Obviously.
Absolutely not. This b, when we shift it over, has nothing to do with being divided by h. This should be 2a over h all by itself, just like this expression up here, minus b, all by himself, is equal to big B. Now, do you want to see what the equation equals if I distribute? Okay. It's going to equal something similar, but it's not going to look exactly the same. So if we go back to this step, and we distribute, I'm going to write it, usually you're supposed to go alphabetical order, but I'm going to leave the H in front. What am I solving for? Him. So what would I move next? Mm-mm. If this was 10 equals 5x plus 4, what would you move next?
H small b.
Yeah, the h small b, right? And I would subtract it over to the other side. So this becomes 2a minus hb is equal to h big B. Right? You're shifting. It's a piece of a puzzle. When you move it over to the other side, it becomes negative. Because what you're solving for, you don't want to move. And you don't ever want to divide when there's sums and differences because things get weird. Plus, other weird things could happen. H could equal 0, and then you're causing all kinds of problems. Now, focus back to the b. How do I get b by itself? Divide by h. So here we're going to get b is equal to 2a minus hb, all divided by h. Now this one is all divided by h. It is the entire left-hand side being divided by h. Are these two answers exactly the same?
Yeah.
And the answer is yes. What's the difference? Well, this one, if we got a common denominator, we'd multiply the bottom by h and the top by h, and we'd have this little bh here, and that's exactly what's over here. So either way you want to do it, it's perfectly fine. If you leave your answer like that, I'm happy. If you leave your answer like this, I'm happy. But I highly suggest you distribute. Follow those steps exactly the way they show up in your book. I don't have enough room. I'm running out of time. That's all right. When I was in 8th grade, my teacher gave out a worksheet of 25 problems. And they looked like this. 2x minus 5 equals 4x plus 7. And then the next one would be 3x plus 2 equals 7x plus 4. And 25 of these problems. And she wanted us to solve all of them. I got sick after doing 2 of them. Because you're doing the same steps over and over and over again. So what I wrote on my paper was this. ax plus b equals cx plus d, where a, b, c, d were the numbers that were on the paper. So what I actually did was come up with a formula how to solve all 25 of them. It took me 5 minutes to do the worksheet. My teacher hated me. My teacher hated me a lot, trust me. Because I was always finding shortcuts that weren't available to everybody else. So what I want to do with this problem, you'll find if someone's good at math, there's only one reason they're good at math. They're lazy beyond belief. They will work their butts off to find an easier way to do something because they don't want to do it the hard way. They want to find some way to do it nice and easy. That's what makes good mathematicians. So, I'm very lazy, yes, I admit it. How do I solve for x? What would be your first step?
Get that.
Don't you dare say get x by itself.
No.
Yeah,
I
all
was
the
gonna say
X's on the
on the
same
same
side.
Get all the x's on the same side. Which one do you want to move?
CX.
Cx. Now, if I move cx to the other side, it becomes ax minus cx. What else do you want to move?
The B to
The B to
The b to the other side. So I'll take this b and shift it the other direction. So on the other side, it becomes d minus b. And now we go back to the first day of class.
Then you can pull that
What
x
is
out of both.
ax minus cx equal to?
X
Times-
parentheses a minus c.
So it's the quantity a minus c. I always put my variable last. D minus b. Factor it out. Distributive property backwards. Anti-distribute, whatever you want to call it. But it's technically, the shortcut name is combine like terms. All right, now I have one instance of x. What do I do next?
Divide quantity of a minus c.
Over to the other side. So you get d minus b over a minus c. Now let me show you how this little formula works. This is a formula, and it works to solve this equation. If you have 2x minus 3 is equal to 5x plus 7, my formula says that this is equal to, what number represents d? 7. Minus, what number represents b?
negative 3.
-3. Notice I put the negative in parentheses. That's to make sure I don't confuse it with the minus. -3. Over, what's a? 2. Minus c? 5. So the answer to this problem is 10 over -3 or -10/3 without doing any work. Isn't that neat? No, you cannot use that on the test. if you can memorize it. All right, hardest one I can come up with. You will, and this will show up later in the semester, have to be able to solve this. I will be asking you to solve this equation later, and I will expect you to know how to solve it before I show it to you again. That's how important this one is. But the steps in solving for the variable x in this case is the exact same steps as solving a linear equation. Step number 1, get rid of all the fractions. How do I get rid of the fractions in this equation? Multiply both sides by 5 plus x. So multiply this side by 5 plus x. Multiply this side by 5 plus x. That'll get rid of any fractions that you see up here. So left-hand side becomes 5 plus x times y. The quantity 5 plus x times y is equal to, what's the other side equal to?
Quantity 3x 1 minus 4.
Do I need the parentheses?
No.
No, just 3x minus 4. Okay, so we got rid of the fractions. Step number 2. Distribute. 5 times y is 5y, plus x times y is xy, is equal to 3x minus 4. Now the third step is combine like terms, but there's nothing to combine. What's the next step?
Moving that 4 over to the other side.
Nope, I don't care about the 4. What do I care about?
Get that y by
No.
get the x.
I care about the x.
Move this 3x to the left, right?
I need to get these x's on the same side. They're on opposite sides. I could care less about the 4, the 5, the y. I don't care about any of that junk. My focus should be on the x's. Now, which one do you want to move?
Minus xy.
The xy? Okay, let's move the xy across. So if we move the xy across, shift it, it becomes negative xy on this side, right? Now, if I'm moving the xy in this direction, what else do I want to move?
That's 4.
That 4. So I'm going to take that negative 4 and shift it the other way. Remember, they have to change signs. So now this becomes 5y
That's 4.
plus 4 is equal to 3x
Minus xy.
minus xy. There. Looks a little prettier. So now I'm down to step 4. I got the x's on the same side. I got the junk on the other side. Step 5.
Divide everything by y.
Stab, die.
Uh-uh.
Focus should always be on the variable you're solving for. I could care less about y.
Yeah, but if you divide a y, it gets away from the x.
Only the one of them, but it introduces it to the other. But that's what I'm saying. Your focus should always be on the variable you're solving for. I don't care about the y. Distribute it out. Kick it out. There's 2 of them. There's one here, there's one here. Kick them out. So this side becomes 5y plus 4 is equal to the quantity times x. Kick that x out. Factor it out. And I distribute it. What's left behind? 3 minus y. Now you're down to 1 instance of x. That's very important. Get it down to 1x. So how do I get x by itself now? Divide both sides by 3 minus y. So you get 5y plus 4 over 3 minus y. And not one time did I get away from the steps of solving a linear equation. They're all there, and they help you do every single one of these. So if you get lost, you go back to the steps and you do it one step at a time. No shortcuts.